Hi folks, we're going to take a look at an example of sketching the graph of a reciprocal trig function. So here we're going to sketch a secant function, all right? And one way to do this, of course, is to pick some important points on the secant function and transforming them using these parameters, all right? But when we're graphing secant and cosecant, there's actually a quicker way to get there. And we can use the fact that the secant function with these transformations shares some properties with the cosine function with the exact same properties. All right, so that's going to be our method here, is to first graph the cosine function with the same transformations, and then from there use that graph to get the graph of that secant function. But of course, before we start, we're going to need to factor our input here. Okay, so -2 secant of, and I'm going to just factor out whatever the coefficient of x is, which is 0.5. So it's going to be x plus. Now here you can intuitively, think about half times what number would be equal to pi over 8. And of course, that would just be half of pi over 4. Okay, so if you multiply this out, you get your pi over 8. Now, just in case you don't want to kind of do this intuitively, of course, the way in which we factor out a number is to divide it out. So otherwise, what you could just do is take your pi over 8 and divide out 1/2. And of course, pi over 8 divided by half is the same as pi over 8 times 2 over 1, which is just pi over 4. Okay, so however you do it is fine. And now what we're going to do, as we said, is we're going to start by sketching the graph of the cosine function, which has the same transformation. So -2 cosine of 0.5 x plus pi over 4, all right, plus 1. Okay, and obviously if it was a cosecant function, I'd be doing this with sine. Okay, and again, we had observed that there are relationships between this function and this secant function. Now be careful, this does not represent the reciprocal of that function there, okay, but they do share some characteristics in common. All right, so let's start listing off our characteristics. So our amplitude would be the 2. Forget, it's not the -2, but just the absolute value of that, 2. And here we have our C value. So from there, we can find our max and min. So the max will be just 1 plus 2, which is 3, and the min will be 1 minus 2, which is -1. And then we're also going to draw our axis, and we'll see why that's going to be important later on. So that's y equals 1. All right, we have our k value of 0.5, so that allows us to find our period. So here our period is going to be 2 pi divided by 0.5, or a half. And as we said before, dividing by half is like multiplying by 2. So that's just going to be 4 pi. And then, of course, we've got our phase shift, which is pi over 4 to the right. To the left. Okay, because it's x plus pi over 4. So pi over 4 to the left. All right, so now that we have this information, we can sketch the graph of this cosine function. But what we want to do is we want to build the structure of this graph carefully. Okay, so we know that for the period, we want to break this up into 4 equal parts. Okay, so 4 pi divided by 4 is just pi. So I'm going to have these x values go up by pi. And then for the y values, well, we're going from -1 to 3, so it makes sense to go up by 1 unit each. Right, so since I'm going to be moving pi over 4 to the left, I'll move my y-axis a little rightward to give myself some room to do that phase shift. Okay, so there's my y-axis, and then my x-axis, well, it's going from -1 to 3, so I guess I'll bring it down a little bit to leave myself some room. So here, in fact, maybe we'll leave it, no, let's leave it there. All right, so there's my x-axis, and as we said, we're gonna have each tick represent pi units, essentially just a quarter of whatever my period is. So this is pi, 2 pi, 3 pi, 4 pi, and so on, here -pi. And then for our y values, this will be -1, 0, 1, 2, 3. All right, so from here now, as I'm going to draw the lines y equals 3, y equals -1, and y equals 1, that's going to help me draw my graph nice and neatly. All right, so just draw some dotted lines here for my maximum. This represents the middle or the axis. All right, and finally, the minimum. And now I'm ready to draw my graph. But what I'm going to do is I'm going to first draw the main points of this cosine function without the phase shift, and then from there I'm just going to shift those all those points to the left by pi over 4. Okay, so notice here that the parent is negative cosine. So at 0, if I'm not shifting it yet, I would be starting at the minimum, and then this would go to the middle, and then to the maximum, and then back to the middle. And so this is why it's nice to draw those lines, because now I don't have to think about where these points are going to be. I can just easily plot them. Okay, and in fact, we can even go to the negative, so middle and maximum. All right, so now what I'm going to do is I'm just going to shift them over by pi over 4 to the left. Okay, so if one tick represents pi units, so pi over 4 would be about a quarter of that. So I don't expect it to be perfect, but it should be reasonable. So since this is divided into 5 parts, a quarter would just be a little more than 1 mini tick. Okay, oh, sorry, so that's, I just realized this is the point, so ignore that one there. There we go. And then this is going to move to the left, and this is going to move to the left, and all of these will move to the left by pi over 4 units. Okay. So notice here, I'm setting myself up to draw 2 cycles. So now what I'm going to do, and I'm going to draw it pretty lightly here, is we've got our cosine function. Now we'll sort of see that it's not actually necessary to draw the cosine function. We'll see in a minute why it's not exactly necessary to draw the cosine function. But it does sort of give us a nice sort of starting point, because in the end, what's important are all these points that I've drawn. Because remember, we talked about this relationship between this cosine function and this secant function. And the relationship is that they share maxima and minima. Okay, and the other thing that we can get from this graph here is wherever my cosine function crosses the axis is going to be the location of my vertical asymptotes. So probably easier to draw those first. Okay, so wherever this function crosses the axis, we saw that we were going to have a vertical asymptote. Okay, so I can just draw them here. Oh, draw it a little nicer there. Okay, there's another vertical asymptote, and there's another one, and this will be the last one I'll draw here. All right, and we said that they share maxima and minima. In other words, wherever the cosine function has a minimum value, that's going to represent a maximum value for my cosine function. And I know the shape, okay, it kind of looks like a bit of a flattened out parabola, and I can now just start drawing my function. Okay, this maximum of cosine is going to be a minimum of my secant, and it's just going to follow the asymptotes. Okay, and I'll just keep drawing until I have 2 cycles. So I've drawn 1 cycle, and now after this next little branch, we'll have our 2nd cycle. All right, and there you have it. So the blue function here is the secant function. So we see that it has maxima at negative pi over 4, and at this point here, and then it's got its minima at these points, and then it has the vertical asymptotes wherever the cosine function crosses the axis. Okay, so just to recap, we'll take a look at the graph on Desmos in a second. So just to recap, we graph this secant function by first graphing the cosine function with the exact same transformations, and then once we have this, the maxima and minima of the cosine function become our minima and maxima of the secant function, and wherever the cosine function crosses the axis are where our vertical asymptotes are going to be located. Okay, so let's take a quick look at the graph on Desmos. Okay, and we see here, in fact, let's take a look at the graph that we have, and we see that, hey, look where our look at where our asymptotes occur. Okay, exactly pi minus pi over 4, which is what we have right here, our vertical asymptote. And let's look here at our maximum, negative pi over 4, negative 1, exactly what we have here, and our minimum at 7 pi over 4 and 3, which looks to be exactly what we have there. All right, that's it for this one.